So I'd like to continue with the matter example. So we will write first the interface. So I'd like to show you the difference between the interface and the abstract methods. In interface, again, everything will be abstract, so I don't need to have the abstract keyword. However, if you want to include, that's okay also. So if you want to write the interface that's going to have, for any matter class that you're going to implement, you will have the public double, and then you have the get volume, and then also the get mass methods, which will not be implemented in the interface. So basically, this is the way you will be declaring your method.java. And so let's say I'd like to create another file that's going to be, let's say, cube method. So how am I going to write this? Public class, right? Cube method, which is going to give the definition of my cube method, which is going to basically implement, right? Implements. What am I going to implement? Method, and then I will have this class started. So let's say I'd like to define a density, public double density. Let's say I initialize this to be equal to 1. And then if I have, let's say I'd like to have a cube that is going to have an edge, double edge, and then I would like to assign this to equal to 1 again. And if I want to have a method that's going to return me the public double get, and let's say I'd like to say density, how am I going to get the density? So basically it's going to return density value, right? So this is going to be the get density method. And what are the other methods that I need to implement? I need to get the mass. So how am I going to get the mass since it implements this interface? Again, I have written the interface which has two methods, get volume and get mass. Since I'm implementing the interface in my cube method, I will have those two methods, get density and then also get mass. So I will have the same method. I'll copy it, public double get mass. So what is it going to calculate here? How am I going to get the mass? Density times volume, which is going to be basically edge times edge, right? So this is what is going to be returned by the get mass. So if I want to, in addition to this, if I would like to have an additional method, so I can add more methods to whatever is available in the interface, I'd like to have a get volume, for example. So how am I going to write the get volume? In matter, there is only get mass and get volume. Oh, sorry. I have to write, I'm sorry, get density is not part of the interface, so it doesn't really need to be there. But for get volume, since it's part of the interface, both get volume and get mass must be there. So I will have here for the volume, what am I going to return? I'm going to return edge times edge times edge, right? So it's going to basically multiply all the edges to get the volume. So if I would like to have another class, so I will have new file. So that's going to be, let's say, sphere method. So what am I going to have? I'll just copy things from here. This is going to be sphere method, which is going to implement the method again. I will have a density similarly is equal to 1, and then I will have in sphere, what can I have? I will have the radius, right? So I will have radius that's equal to 1, and then the density will be returned again with the get density method. If I'd like to have the get volume and get mass, how am I going to get the mass? What was the mass for a sphere? pi, right, times, what was it? So I will have radius times radius so I will have the times 4/3 times density. So this will return me the mass, and then for the volume I'll just have this part, right? So that should give me the volume, and so this is how you would. Okay. So this will be the sphere method, and then I have the cube method. So as you see, this is how interface and classes will be implemented. Interface only defines the methods that you can write, and then you extend, you implement the internal meanings of the methods. Again, these are abstract methods, even if you have not written abstract here. However, if I'd like to implement this in a different way using the abstract classes, and I define a new class which is going to be, let's say, body.java, and I will have an abstract class, public abstract class, what was the name, body, right? And I'm going to have certain methods here that are going to be abstract, and certain methods that will implement the actual internal meaning of the method. So what are the methods that I can declare as abstract in the previous interface example, and also the cube method and sphere method? So which one of these I can write as abstract? So if I would like to write these two methods, right? So which ones I will have? So let me declare public double density equals 1. And then if I'd like to write these methods, which ones should I have as abstracts? So which ones do have actually same meaning or same method declaration here? So when you look into the mass, how do I get the mass? I use density times the volume for both cases, so I can use it as a common implemented method rather than implementing separately for within each class. However, for the get volume, I need to have it abstract. Why abstract? It will be different for sphere and cube. Does it make sense? So let me write the code, and then you can see the difference. So as I said earlier, I will have the public abstract, double abstract get volume, right? This is going to be an abstract method. However, this one get mass will be implemented as a method. So I'm going to write it as return density times what? I will call get volume. Okay? So this is basically the implementation of my abstract class body, right? If I'd like to implement my cube body, for example, file, and then I have cube body.java. How am I going to implement this? So basically I will have this and copy it from here. In my cube body I will have public class cube body. Then what will I have? extends, right? Extends body. Then what will I have? In body, I have already implemented this getMass method, so I will just need to have the getDensity. So this is already defined there. And I will have the getVolume, which will return this. Okay? So as you see here, I have the getVolume method implemented specifically for the cube, which is going to basically return edge by edge by edge. And then the getMass method will be used from the main class, the parent class, which is the body. So it's already available here. And again, if I would like to implement sphere, so what will I do? I will create, let me create the new file. So this is going to be sphere body.java. And then I will again copy the sphere method implementation from here. And in which case I will have sphere method implements. No, this is going to be sphere body. Extends, right? Extends body. Then what will I have? Again, density is already declared in the main class that I'm inheriting from. So I'll get rid of that. And then getDensity will implement this as this way. And also, I will have getVolume implemented separately here, since it's going to be, different from the base class. So that's going to be getValue. Again, if you look into here, this getDensity, can I get rid of the getDensity method also? Yes, right? I can just get rid of these two methods, and it will implement it for me. So it's going to be implemented here instead. So basically, I have getDensity implemented here. Okay, so this is the base class, which is an abstract class. Again, if you want to create an object using this body, you won't be able to create. It's just an abstract class which builds a base thing to start from. Okay, so whenever you create an object, you create it from one of these cube body or sphere body by initially creating the object from. And the abstract method is implemented separately by whoever extends this. However, the rest of the methods will be able to use from the base class that are not abstract. Any question? If you want to, if you need to use getDensity method, you can implement. However, if you don't need to, that's also fine. It's already public, so probably we should have defined this, it as private. So that's why it should have been private instead of public. Okay. Any question? Okay, so this is about. Yeah, sure, I can send these files. Let me save after the class and I will be able to send them. Okay. So this is the difference between abstract and interface. So if you need to be clear on abstracts and interfaces as well. So when you look into the interfaces, you can have interface hierarchies as we had with the class hierarchies. So you have an interface that is implemented by another interface and then another interface and so on. So you can have a hierarchy of interfaces and also separately a hierarchy of classes. However, you cannot mix them. So you have a class hierarchy which uses or implements one of an interface hierarchy, and then you again generate another interface from there. That's not possible. So if you have an interface hierarchy, you can use it, but it needs to be separate from the class hierarchies you have. So you can have this implementation if it is good in terms of your application. So when you look into the visibility of the variables that you have, so it's when all variables and methods of a parent class will be available to the inherited children, so the children will be able to access the parents variable. However, you need to use, if you want to access the private members that are inherited by the child class, you need to access them indirectly. How are you going to access them? You will use the super reference to access those variables if you have a certain other variable that is using the same name. So if I go ahead and show you this example, food analyzer, food item, and then I have pizza. So as you see, we have the food item class, which is public class food item, and then there is a constant final private int calories per gram, and then you have a private instance variable, fat grams, and then also a protected variable, the servings, which will be available to the children that are going to extend from this class. And I have a public constructor which is going to take the number of fat grams and then number of servings and assign those variables. And the next thing we have here is that it calculates the calories by just calculating the calories per gram times the fat grams, and then you have the calories per serving. You divide the calories and divide it by the servings, you get the result. So when you look into the pizza.java, it's basically extending the base class, the food item, so it's a child of that class. It has all those previous methods. On top of that, it has an additional constructor, which is basically going to create its own object by calling the base classes constructor. Again, you have the fat grams and 8, so that you create the base object first, and after that this is going to be created afterwards. As you see, what's the idea here? Why do I have this constructor? So in food item we had the fat grams plus the number of servings, if you remember, in the constructor. However, in this case, for pizza, you already know that the number of servings per pizza is 8. That's why you give it as a constant, and then just take for pizza only one parameter as the constructor. So whenever you create this object, it calls its parent object and creates a parent object with fat grams by 8. So basically, this is only changing the constructor and nothing more than that, specifically for pizza. And if you look into the food analyzer application, so you create pizza special new pizza 275, so it gives 275 by 8 to the base class, the parent class, and then prints the method that is, this was, remember, the method of the main class or the parent class, so it's going to call the parent class's calories per serving method. Okay? So for designing for inheritance, as I said earlier, you need to provide a good design to have a good object-oriented program at the end, and to do that you have to utilize whatever is written before. And in order to be able to use this previously available applications or program pieces, you have to have a hierarchy that is composed of common characteristic at the top. So you have the top class that has all the common characteristics of all the subclasses, and implement those at the top, and then add as necessary as you go down to the below or lower levels of the hierarchy. So if you find a functionality of a child is common, you move it up. If you find it is as specific as possible, you take it down all the way possible. And then, as I said earlier, shadow variables are avoided as much as possible. And whenever you have a child, you first construct the super or the base classes constructor by calling the super method, and always implement the string to string and then equals method for your classes, even though there are already available ones. And also use the abstract classes if you have general knowledge of certain classes that are going to be using those abstract classes. And as we said before from the beginning, visibility modifiers are critical. Use encapsulation, do not violate it, with using public variables if they're not necessary. And if you have final modifier in inheriting classes, if you use the final modifier, you won't be able to inherit from that class. So if you want to limit the inheritance, cut it there. You would like to use final such that it won't be able to extend it further on. Okay. So we will go into the inheritance and the GUI components. So before going into that, I would like to stop here, and we will have a quiz now. So let's stop. I will have it.